Monday, first you'll practice whatever taught in class. Tuesday, current electricity MCQ 1 to 20. Wednesday, whatever taught in class, practice 2 times. Thursday, current 21 to 40. Plus friction. Friction ka questions I will send you from that. 5 will practice. Total 25 I will send. Friday, whatever taught in class 2 times. Saturday, current electricity 41 to 60 plus friction. Sunday, test on current plus friction MCQ. Please complete this much. Write this properly. Weekly planner. Extra lectures. Hello.
Yes, sir.
Today, anytime you are free after this lecture, I will tell time. Huh? Don't take any tension. I'm just telling the time. Between 3:30 to 7. Are you free anytime? Between 3:30 to 7.
Yes, sir.
What time you all are free? Between 3:30 to 7.
Whole,
Pardon?
whole.
Full time you are free?
So after 5 today.
After 5. That
Yes,
means
sir.
After 6.
from 6 to 7 everybody is free? 6 to 7?
Yes, sir.
Sir, on which
Yes.
day?
Today, Monday.
Yes, sir.
6 to 7 everybody is free Monday?
Yes.
Monday means
Yes.
today's day I'm asking. Okay, everybody is free. Tuesday, what time you all are free? 9 to 10 evening you all are free? Evening 9 to 10?
Yes, sir.
Yes, sir.
So 2 extra lecture write down. Today 6 to 7 evening and tomorrow 9 to 10. Please write down properly because we require few extra lecture to have grip on the syllabus. Have you written? Today is Monday, extra lecture 6 to 7. Then Tuesday 9 to 10. This is evening slot. Yes, everybody has written this information.
Yes, sir.
I'm just clearing this off. Now, what we have done in last class, have I done condition for balanced Wheatstone's bridge network?
Yes, sir.
Okay.
Yeah.
It was R1 upon R2 equal to R3 by R4, correct na?
Yes, sir.
One note write down. For balanced Wheatstone's bridge network, there are several conditions. First, no current should flow through galvanometer. No current should flow through galvanometer. Second, the product of resistance in opposite arms must be same. Product of resistance in opposite arms must be same. Third, the ratio of resistance in left hand side of galvanometer must be same as resistance of right hand side of galvanometer. Fourth, resistance above galvanometer must be same ratio of resistance above galvanometer must be same as below. That means if this is galvanometer, these are left and right ratio and these are above and below ratio. Fifth, potential difference across galvanometer, potential difference across galvanometer must be same, must be zero. Potential difference across galvanometer must be zero. Potential difference across galvanometer must be zero. Shall I clear this?
Just a second. Done, sir.
Okay. What is resistance formula in terms of dimension? Is it rho L by A,
Yes, sir.
where rho is called as specific resistance, L is length, A is area of cross section. So R upon L, can I say it is rho by A? Can I say?
Yes.
Yes, sir.
Rho means constant or variable for given conductor?
Constant.
Constant, correct. Area of cross section for given conductor? Also constant. So can I say this ratio is constant?
Yes, sir.
Yes.
So resistance per unit length is a constant quantity for given conductor. So if I just names, let sigma be resistance per unit length. So if I tell resistance, can you tell me sigma value? Sorry, if I say length, can you tell me resistance value? Length is 2 meter. What is resistance? R upon 2. So can I say 2 sigma?
Yes.
Yes.
If length is 3, then how many sigma? Very good, very good. Length is 4, then 4 sigma. Length is Lx, then
X.
sigma into Lx. Length is Lr, then sigma into Lr. Okay, just keep this in mind. We'll require somewhere. Next heading. Meter bridge. Earlier, last class we did Wheatstone's bridge. Now it is meter bridge. Mostly numerical will come on this. Theory, chances less. The practical form of the practical form of Wheatstone's bridge is called as meter bridge. The practical form of Wheatstone's bridge is called as meter bridge. That means actually it is Wheatstone's bridge only, which we use in lab, so that we can do some changes very fast. Now let us see how it will look like. Then I will explain how that will be same as like Wheatstone bridge. It consists of uniform wire AC, usually 1 meter long, fitted at the ends of two copper strips. Fitted at the ends of two copper strips. Fitted at the end of two copper strips. Just wait, huh? Fitted at the ends of two copper strips, bend at right angles. Now we can think how it is. It consists of uniform wire A, C, usually 1 meter long, fitted at the end of two copper strips, S1 and S2 bend at right angles. Third copper strip S3 is mounted in such a way that two gaps are obtained. One gap, two gap are obtained. In the left gap, unknown resistance X is connected. In the right gap, known resistance R from resistance box is connected. Resistance box will contain resistance which can be changed. Since it is like this, one rectangular box is there. Here we have key 1 ohm, 2 ohm, 2 ohm, 5 ohm, 5 ohm, 10. Whichever key you remove, that gets connected in the circuit. So it is known and variable resistance. That means I can vary the resistance. I know the value of resistance. Rheostat means you can't vary. You can't know the value. So it consists of uniform wire AC, usually 1 meter long, fitted at the end of two copper strips S1, S2 bend at right angle. Third copper strip S3 is mounted in such a way that two gaps are obtained. In left gap, unknown resistance X is connected. In right gap, known resistance R from resistance box is connected. The junction B of known and unknown. अभी this is known, ये copper strip, ये unknown, और ये दोनों का जंक्शन मतलब ये वायर ही है ना, because it is copper. So this is connected to one end of galvanometer. Galvanometer is a device which records the flow of current. It will not show magnitude of current. And other end is connected to jockey. Jockey is like one pencil-like structure. Here it is copper coated. Then one wire gets connected. So whenever you connect this jockey, that means you are connecting wire to this point. Junction B of known and unknown is connected to one end of galvanometer, other end of galvanometer is connected to jockey, which can slide over wire easy. Battery of EMF E, comma plug key K, battery of EMF E, comma plug key K, rheostat RH are connected in series across wire AC to send constant current. Diagram any difficulty? Hello?
No, sir.
Just write this practical form of Wheatstone bridge is called meter bridge, then draw diagram. Then I will explain construction and working. And third will be uses. Mostly, as I said, they will ask numerical on this topic. Yes, completed.
Done, sir.
Okay. The practical form of Bridgestone's bridge is called as meter bridge. Then you have drawn diagram, correct ना? ये डायग्राम में इधर LX और यहाँ पे LR लिख लो थोड़ा, LX LR. Now write down. I'm just clearing the diagram. We are explaining construction. It consists of uniform wire AC, usually 1 meter long. Usually 1 meter long, fitted at the ends of copper strips S1, S2 bend at right angles. A strip S3 is mounted in such a way that two gaps are obtained. It consists of uniform wire AC, usually 1 meter long, fitted at the ends of copper strips S1, S2 bend at right angle. A third strip S3, a third strip S3 is mounted in such a way that two gaps are obtained. In left gap, unknown resistance X is connected. That means you have to calculate value of this. And in right gap, known resistance R1, known resistance R from resistance box is connected. The junction B of known and unknown resistance is connected to one end of galvanometer. The other end of galvanometer is connected to the jockey, which can slide over wire is. Just complete this. Yes, completed. Hello.
Yes, sir.
Completed writing. It can slide over wire AC tak.
Yes, sir.
Okay. Everybody is done. Can I clear this?
Yes, sir.
So, a battery of EMF E, comma plug key K, comma rheostat RH are connected in series to send constant current I. To send constant current I. So this completes our entire construction which we have drawn in the diagram. Now how it works? By inserting plug key, K and removing suitable resistance from resistance box. Suitable resistance from resistance box. Suitable resistance means if this is one strip, second strip, third strip, and here there is resistance box and this is galvanometer. If you touch the jockey here, then if deflection is to the right, when I touch here, it should go to the left. So somewhere I will get zero wala point. That point is called balance point. Balance point means no current is going through galvanometer. Then I can use my condition for balanced Wheatstone's bridge. But suppose when you touch on A, deflection is galvanometer to the right. When you touch at C, still it remains at right. मतलब ये बीच में कभी आएगा नहीं. तो आपको ये resistance कम ज़्यादा करना पड़ेगा. That is called suitable resistance. We have to remove from resistance box. So by inserting plug key and removing suitable resistance from resistance box, by inserting plug key and removing suitable resistance from resistance box, current is made to pass through the circuit. Current is made to pass through the circuit. Copy this much first, okay? Again completed.
Yes, sir.
Okay. So by inserting plug key, current is made to pass through the circuit. Now by sliding jockey, a point D is obtained at which galvanometer shows no deflection. At which galvanometer shows no deflection. This is called as null point. So D is null point at which no current flows through galvanometer and hence it is showing no deflection. This is called as null point. Let Lx, Lr be the distances of null point from left and right end respectively. Then since bridge is balanced, because no current flowing means it is balanced, therefore resistance on left side, एक मिनट पहले मैं लिखा देता हूं फिर आपको डायग्राम बना के फिर से समझाता हूं. Therefore X upon R, which is resistance above galvanometer, is equal to resistance of wire Lx upon resistance of wire Lr. Just copy it till this much. 2 more lines, then I'm explaining with diagram why I wrote this. Now by sliding jockey at point D, sliding jockey, a point D is obtained. Yes, done.
Yes, sir. Done.
Okay, others have also done.
Yes, sir. Done.
Now see, let sigma be resistance per unit length of wire. Let sigma be resistance per unit length of wire. Therefore, resistance of Lx will be sigma Lx. This I explained how. Resistance per unit length is sigma. So if length is Lx, resistance will be sigma Lx. Resistance of Lr will be sigma Lr. Therefore, x upon r is sigma Lx upon sigma Lr. So x upon r is Lx upon Lr. Therefore, x is r into Lx upon Lr. Using above formula, unknown resistance X can be determined. Now copy full. साढ़े 17 का याद है 21 हो गया भाई मैंने 34 रखा है एक दिन रुको क्या आज जस्ट स्टार्ट हुआ ना क्या बोल रहे हैं क्या सब लोग लॉस लगा है 20 रुपए हाँ 20 रुपए का लगा है ना Yes, completed.
Yes, sir. Done.
Okay. Let's see. What I was telling, it is practical form of Wheatstone's bridge is called meter bridge that we'll analyze. A, C, D, Lx, Lr, X, R, and this is point P. Now, if I look carefully, A, B, C, D. A and B का बीच में there is resistance X. A and D wire Lx whose resistance is sigma Lx. B and D galvanometer. B and C known resistance from resistance box. C and D wire with sigma Lr. A and C battery. Plug key rheostat. Battery plug key rheostat. Now is it like Wheatstone bridge only, see, which I converted?
Yes, sir.
And when no current flows through this, then it is balanced. So resistance above this is X upon R, below is sigma Lx upon sigma Lr. इसलिए मुझे मिल गया X by R is Lx by Lr. I hope followed.
Yes.
So we did Kirchhoff's current law, Kirchhoff's voltage law, Wheatstone's bridge network, meter bridge. Next topic. Potentiometer. Potentiometer. Now, as the name suggests, it will measure something, correct? Na? Meter means some measuring device, no?
Yes, sir.
Yes, sir.
So definitely potentiometer will be potential measuring device.
Yes. Yes, sir.
But some advantage over voltmeter, some disadvantage. So we'll see what is potentiometer. So पहले what is potentiometer लिख देता हूँ. Then principle we'll see. Then its uses. Potentiometer. It is a constant current potential measuring device. That means current is constant and then it measures potential. So it is constant current potential measuring device. Principle means how it works. Important topic. It consists of uniform wire AC, usually 8 to 10 meter long, having uniform area of cross section A, specific resistance rho, length L, stretched on a wooden board. Stretched on a wooden board. So this is wire AC having length 8 to 10 meter, constant area, specific resistance, length stretched on a wooden board. A battery of EMF E, comma, plucky K, comma, rheostat are connected in series across wire AC to send constant current I. Let PQ be small segment of potentiometer wire AC having length L. So can I say its resistance will be rho L upon area, resistance of PQ? Hello?
Yes, sir.
Okay. Let V be the potential drop across PQ. So by Ohm's law, what is voltage? By Ohm's law? Is it IR? Correct. IR. R is rho L by A. I constant है क्या?
Yes.
Okay. Rho ये constant है?
Yes.
Yes.
Constant है. A is also constant. So V is some constant K into L. That means V, I can say proportional to length. I hope you followed. V is proportional to length.
Yes, sir.
Yes.
So that means I can say one conclusion. When constant current flows through potentiometer wire, very important word. When constant current flows through potentiometer wire, then potential drop across any segment is directly proportional to length of that segment. This is principle of potentiometer. Again, when constant current flows through potentiometer wire, then potential drop across any segment is directly proportional to the length of that segment. This is principle of potentiometer wire. Clear? Hello?
Yes.
Okay, just draw the diagram, then again I am discussing theory. Draw diagram. This topic is one of the important in current. One sum is fixed. Drawn the diagram.
Yes, sir.
Okay. We are writing now explanation of principle of potentiometer wire. It consists of uniform wire AC. Here don't write length because it is nearly 8 to 10 meter. Uniform wire AC having uniform area of cross section A, comma, specific resistance rho, comma, length L, stretched on a wooden pole. A battery of EMF E, comma, plug key K, comma, rheostat RH are connected in series across wire AC to send constant current I. Wire AC to send constant current I. Let PQ be small segment of potentiometer wire AC. Let PQ be small segment of potentiometer wire AC having length L. Therefore, resistance of wire PQ, comma, R equals to rho L by A. Let P be the potential drop across PQ. Therefore, by Ohm's law, V equals to IR. Just complete till this. Yes, completed till V equal to IR.
Yes, sir.
Everybody is done till V equal to IR. Hello?
Yes.
Okay. V equals to IR. Therefore, V is I rho L by A. I rho A are constant. Let I rho upon A equals to K equals to constant. Therefore, V equal to KL. Therefore, V is proportional to length. Thus, when constant current flows through potentiometer wire, when constant current flows through potentiometer wire, then potential drop across any segment of potentiometer wire, then potential drop across any segment of potentiometer wire is directly proportional to the length of that segment. When constant current flows through potentiometer wire, then potential drop across any segment is directly proportional to the length of that segment. This is principle of potentiometer wire. Now copy. Yes, completed now.
Yes, sir.
This is principle of potentiometer. Note right down. K equals to I rho upon A, or K is voltage upon length. It is called as potential gradient. It is called as potential gradient. Copy.
Done, sir.
Explain method of comparison of two cells. Method of comparison of two cells using potentiometer by individual method. Explain method of comparison of two cells using potentiometer by individual method. By individual method means first we have to connect one cell, then connect another cell, then compare. This is the meaning of individual method. But our device to be used is potentiometer. Comparing means ratio. Right heading, then I am drawing diagram. Next lecture, theory of this topic will get completed.
Done, sir.
So whenever it is given using potentiometer, your first paragraph or diagram will be fixed. First, this part of diagram will be fixed. That means this is AC connected to battery of EMF E, lug key K, and rheostat RH. This is fixed. To supply constant current I, this much fixed. Always with A positive terminal of the batteries are connected, whether one battery, two battery, 10 battery, but A is connected to positive terminal. So I can see that positive terminal of E is connected to it. Now this cell whose EMF we have to compare, its positive terminal M. Positive terminal M of battery of EMF E1 is connected to A. Negative terminal N is connected to one end of galvanometer. Other end of galvanometer is connected to jockey, which can slide over wire AC. By sliding jockey, null point P is obtained. Null point P means when galvanometer is not showing any deflection. Let L1 be its distance from left end. Then once we have done all this, we remove E1 and we connect another battery of EMF E2 such that E2 is less than E1. अगर voltage कम तो उसको balancing length भी कम लगेगा, because balance करने का length is KL2 हो जाएगा फिर by principle of potentiometer. So this dotted I am showing for second battery, it will be having length lesser than L1 because I am assuming that its EMF is less. EMF is less मतलब उसको balance करने के लिए voltage भी कम लगेगा. So only draw the diagram, then I am explaining you everything. Just draw this diagram. And from this chapter, only 2 theories are left out. That's why I'm telling next class we will complete. In fact, this week we'll complete this. So as per our commitment, by May end we'll complete this chapter. So that we'll start June se new chapter, and every month minimum target 2. Just complete the diagram properly so that I can explain you.
Done, sir.
सबका हो गया. अभी एक पार्ट देखना नल पॉइंट पे क्या होता है. This is galvanometer. Yes, Karan, you can hear me? Karan Bora?
Yes.
If this is galvanometer connected to negative terminal of battery and other end is at point P. Avan? Tirtha, Avan?
Yes, sir.
Jasmita?
Yes, sir.
When no current is flowing through galvanometer, no current and no current, then N का voltage ज्यादा क्या P का ज्यादा, or both are same? Yes, Anay?
The same.
Same, sir.
Must be same, then only no current flows, because for current to flow there is potential difference required. So N ka voltage and P ka voltage same. That is called equipotential points. This is positive terminal M connected to A by wire. इसके बीच में कुछ resistance नहीं. Like this is one wire. Here we have A, here we have M. तो इसका voltage अगर 10, तो इधर कितना, इधर कितना, इधर कितना, इधर कितना, इधर कितना. All same or
Same,
decrease?
yeah.
Same, because there is
Same.
no resistance. So I can say now M ka voltage and A ka voltage be same.
Yes.
Correct, na? So if A voltage is 10, so M is also 10. N voltage 5, N is also 5. So what about difference between Mn and AP? Are they same?
Yes. Yes. sir.
Difference of Mn voltage is same as AP का voltage. Mn का difference मतलब ये EMF E1 ना. Potential
Yes.
difference Mn मतलब EMF, and AP का मतलब ये पूरा वायर का potential, ये पूरे वायर कितना होएगा? K times L1 or not, by principle of potentiometer.
Yes, sir.
Yes. sir.
So I'm going to use this principle to compare. E1 is KL1, that means potential difference across Mn potential difference across Mn is same as potential difference. Potential difference across Mn is potential difference across AP. Potential difference across Mn is potential difference across AP. That means E1 is KL1. So if I remove that battery E1 and connect E2, whose EMF is less than E1 at A. So now balancing length will come before P or after P? Tell me.
Before P.
Before P, because voltage come. So इसलिए इधर Q लिखा. Suppose इसका length L2, so I can say E2 is K times L2. So when you take ratio of E1 with E2, KL1 upon KL2, KK cancel. So can I say E1 upon E2 will become L1 by L2? Hello? Hello?
Yes. Yes. Sir.
Now I can calculate this length L1 and L2. Can I compare EMF of two cells now by individual method? Yes or no? Yes, can we compare? If I know L1, L2.
Yes, sir.
So using this formula, we can compare